Welcome to this video in our series, A Beginner's Guide to the C Programming Language. In the last video, we saw how data is stored in memory, encoded, and represented by different data types. In this session, we'll go over the Software Development Lifecycle, or the SDLC. When large applications are developed, the SDLC is a well-defined process that breaks its development into multiple phases and steps. It is needed when you have a large development team in order to collaborate and communicate efficiently. The SDLC defines the steps in the process along with inputs and outputs for each step. The programs that we will write in this course are small and you do not need an elaborate SDLC. But it is good to follow a plan when developing code. And that is what we are aiming for over here. The steps we will follow are: first, define the problem, understand and analyze the requirements, design the solution, code and implement the designed solution, test the code developed, and finally, document the code for others to be able to maintain. We will also understand different tools used to make coding easier. The SDLC helps to design, develop, and test high-quality software. There are many development process methodologies in use. You can create an SDLC using any of these methodologies, like the waterfall model, rapid development model, and the more recent agile development. The waterfall model is a sequential process. Every step provides an input to the next phase of the process. As shown in the slide, the requirement phase is where the user requirements are analyzed and the specifications are documented. This is then the input to the design phase, where specifications are created for developers to develop and test their code. Finally, independent teams of testers verify the product and then deploy it to the users. After that, a successful application would live a long life in the maintenance phase, where it is continuously updated to meet new user requirements. A rapid application development process is an iterative process, where core user requirements are identified to build the first version of the software. The development of this first version may follow a waterfall process to develop and deliver these core requirements to the user. After which, the next iteration is designed with another set of identified requirements. This is repeated until the application is completed. The rapid application development process helps get an early version of the application to the users quickly so that any changes in requirements can be handled better. The agile development process is another example of a software development methodology where the application is developed in a series of releases with an initial set of requirements developed incrementally as per a well-defined time period. We will not use the agile process in this course and will not discuss it further. Let us dig deeper into different steps you will perform when you're developing your application or code. The first step is to understand the requirements of the application or the code that is being developed. This is the problem definition step, where the problem is defined clearly without any confusion. It starts by defining the application's objectives, main requirements, and features. In case of large applications which have many different types of users, this can be broken down into more detailed user requirements, and then further broken down into detailed system requirements. These include functional as well as non-functional requirements. Here are some examples of functional and non-functional requirements. Once requirements are well defined, technical teams will analyze them to determine their implementation. It includes assessing the requirements for feasibility, initial effort, and cost estimation. In addition, an important part of the requirement analysis is to communicate a good understanding of the user's needs to both the users as well as the designers. Different tools are used in this step. These include brainstorming, mind mapping, etc. The most crucial part of requirement analysis is to ensure that each requirement is well defined, complete, traceable, and testable. After analyzing the requirements, the next step is to design the application. The main objective of this step is to create software components and programs that are easy to code and maintain in the long run. This means that the software components should be reusable and work well with each other. At a program level, the program design identifies the inputs to the process, how the program will obtain these inputs, and the algorithm to be implemented. An algorithm is the operations performed on available data in a series of sequential steps. Finally, the program design will define how the program should be tested. A programmer can use tools like pseudocode and flowchart to plan the algorithm. Using these tools help choose the best approach from multiple possible solutions. In this slide, we have shown a well-defined problem definition. This is followed by an analysis of the program's requirement, and once the requirement is clear, a pseudocode developed that will satisfy the user's requirement. As you can see, the pseudocode is a collection of English-like statements that is used to communicate the proposed solution to the developers without bothering about syntax and semantics of any programming language. A flowchart, on the other hand, is a diagrammatic representation of the algorithm. It makes it easy to represent the algorithm to both non-technical users as well as technical developers. Each symbol in the flowchart represents a type of activity. These symbols are well known and easy to understand. A flowchart uses these symbols to specify the sequential steps that need to be followed by the developer when coding. Lines connecting the symbols are called flow lines, and the steps flow from top to bottom in the direction of the flow lines. The next phase in the development process is implementation or coding. In this phase, the developer will simply code the application in the computer language after understanding the requirements and the design of the application. The code will be developed, compiled, and tested to ensure it works as per the specifications. As you can see in this example, the C program code translates the specifications into syntactically correct code. You should see a similarity between the code and the pseudocode developed in the program design phase. Finally, we get to the most critical step in the process, that is testing. This activity ensures that the application is developed as per the user's requirements. There are different types of testing, and we will not elaborate on them. But the testing depends on the application size, criticality, and context. For example, we perform load testing on an application designed for multiple simultaneous users, or a non-functional requirement that specifies the number of transactions it will perform in a unit of time. Load testing will ensure that the application fulfills this non-functional requirement. Testing needs to be a well-planned exercise. The test data, test steps, and expected results are documented so that the team can repeatedly test the application whenever required. This documentation takes the form of a test plan and test cases as shown here. Another reason to perform testing is to ensure that the applications work completely and efficiently when delivered to the user. It also helps maintain a list of defects found in the system and the solution implemented to fix them. This provides teams with an excellent tool to learn and prevent future errors. In this video, we have had a brief discussion on the software development lifecycle. As you saw, it is a sequential steps of well-defined activities that take an application from a user requirement stage all the way down to a well-tested and useful product. Please like and share this video. Follow us for more videos on C programming and tutorials on other programming languages. Our next video will dive into the first topic directly related to C programming. That is, we will study the C data types. Until then, goodbye.